Imagine building an app, but never worrying about servers. No server setup, no operating system updates, no scaling issues at 2 a.m. You just write code. That's the idea behind AWS Lambda, and it changed how modern cloud apps are built. Before Lambda, developers had to launch servers for everything. Even if your app had only 5 users, the server still stayed online all day. You paid for idle machines. You managed scaling. You fixed crashes. It worked, but it wasted time and money. AWS looked at that problem and asked, what if developers only focused on code and AWS handled everything else? That became AWS Lambda. Lambda is called serverless computing, but servers still exist. You just don't manage them. AWS manages infrastructure, scaling, networking, operating systems, availability, failover. You only upload your function. A function is just a small piece of code designed to do one job. For example, resize an image, send an email, process a payment, generate a PDF, respond to an API request, analyze uploaded files, run AI workflows. Instead of running a full application on one server, Lambda runs small tasks only when needed. Think of it like electricity. You don't own a power plant at home. You use electricity only when needed and pay for usage. Lambda works the same way. You run code only when triggered, and you pay only for execution time. That's why startups love it. Now let's understand how it actually works. Imagine you build a photo upload app. A user uploads an image into Amazon S3. The moment the upload happens, S3 sends an event to Lambda. Lambda instantly starts your code. Your function compresses the image, creates thumbnails, stores optimized versions, updates a database. Then Lambda shuts down. No server stays running. No engineer manually scales anything. Everything happens automatically. This event-driven model is what makes Lambda powerful. Lambda reacts to events, and AWS services generate events everywhere. Examples: API Gateway receives requests, DynamoDB data changes, S3 uploads files, CloudWatch triggers schedules, SNS sends notifications, SQS receives messages. All these services can activate Lambda automatically. This creates highly automated systems. Now here's where Lambda becomes really interesting. Scaling. Traditional servers have limits. If 1 million users suddenly arrive, your infrastructure can crash. With Lambda, AWS automatically creates more function instances. 1 request, 1 Lambda execution. 1 million requests. AWS spins up massive parallel executions automatically. That's why serverless architecture became huge. Developers stopped thinking about servers and started thinking about workflows. And for many apps, that's faster and cheaper. But Lambda is not magic. It has limits too. One important issue is called cold start. When a Lambda function hasn't been used recently, AWS may need a few milliseconds to start a fresh environment. That startup delay is called a cold start. For small apps, it's usually fine. But for real-time systems, low latency matters. AWS improved this with features like provisioned concurrency, which keeps functions warm and ready. Another limitation is execution time. Lambda functions are designed for short tasks. You cannot run a process forever. If you need heavy long-running workloads, containers or EC2 may work better. This is why cloud architecture is about choosing the right tool. Not everything belongs on Lambda, but many modern systems do. Now let's talk about pricing. This is one reason Lambda exploded in popularity. With traditional servers, you pay even when nothing happens. A server running idle still costs money. Lambda charges based on number of requests, execution duration, memory usage. If nobody uses your app overnight, costs drop dramatically. That makes Lambda perfect for startups, MVPs, automation tools, internal systems, unpredictable traffic, burst workloads. Netflix, Coca-Cola, Airbnb, and thousands of startups use serverless technologies in different ways because operational simplicity matters. And that's the hidden value of Lambda. Less infrastructure management means engineers move faster. Instead of patching servers, teams build features. That speed creates competitive advantage. Now let's compare Lambda with EC2 quickly. EC2 gives you full control. You choose operating system, CPU, memory, networking, storage, scaling setup. It's powerful but requires management. Lambda removes most of that control. In exchange, AWS automates operations. So the real question becomes, do you want flexibility or simplicity? Large companies often use both together. For example, Lambda for automation, ECS for containers, EC2 for specialized workloads. Modern cloud systems are hybrid, and AWS designed its ecosystem that way. Now let's see a real-world workflow. Imagine an e-commerce website. A customer places an order. That single action can trigger multiple Lambda functions: payment validation, invoice generation, email confirmation, fraud analysis, analytics tracking, warehouse notification. Each function does one small task. This architecture is called microservices, small independent services working together. And Lambda fits perfectly into that model, because functions are isolated and scalable. If email notifications fail, payments still work. That improves reliability. And reliability matters at scale. Now let's talk about developers. Why do developers love Lambda? Because it removes friction. You can build fast. A solo developer can launch systems that previously required entire infrastructure teams. That changed startup economics. Small teams can now build globally scalable products. That's a huge shift. But serverless also changes how developers think. Instead of building giant applications, engineers break systems into events and functions. That mindset is very different from traditional architecture, and it's becoming increasingly common in AI systems too. Today, many AI pipelines use Lambda for inference triggers, automation, document processing, embeddings workflows, chatbot orchestration, media processing. Serverless and AI work surprisingly well together because both are event-driven. Now here's the bigger picture. AWS Lambda was never just about saving money. It was about changing developer behavior. AWS realized infrastructure management slows innovation, so they abstracted servers away. And once developers stopped managing infrastructure manually, cloud development accelerated dramatically. That's why Lambda became one of AWS' most important services. Not because it replaced servers completely, but because it changed how modern applications are designed. Simple idea. Write small functions. Trigger them with events. Scale automatically. Pay only for usage. And let AWS handle the infrastructure.